Good morning, and welcome to another Fireside Chat with Mr. Young and special guest, Miss Lauren Elizabeth, who's awake today. And today it's Tuesday, April the 21st, and you can see she's glued to this presentation. So in honor of Miss Kane saying that my math lessons would put people to sleep, you can see Miss Lauren is now wide awake. We'll be identifying and visualizing patterns. So last week we organized and represented fractional data on line plots. You also used operations on fractions to solve problems. This week, what we're going to be doing is using rules to generate sequences, identify relationships between corresponding terms, and graphing points on a coordinate grid to visualize these patterns and these relationships. Today's state standard is to generate two numerical patterns using two given rules to identify apparent relationships between corresponding terms, form ordered pairs consisting of corresponding terms from the two patterns, and graph the ordered pairs on a coordinate plane. Your warm-up is to identify the pattern. So if we look at the first one, 1, 5, 9, and 13, I can see that the pattern in this is each one increases by 4. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13. The next numbers in the pattern would be 17, 21, and 25. I want you to complete the next 5 of these and post it to Canvas. We'll also be working on pages 260 and 261. If you look at the first problem on page 260, what rule could you use to find the next number in this pattern? 1, 2, 3, 4, 5. Well, in this case, you can see that the pattern is increasing by 1. So the n, you can see, is increasing by 1. The next number would be 6, then 7, then 8. In the out, what rule could you use to find the next number in this pattern? 2, 4, 6, 8, 10. Well, obviously this is increasing by 2. The next numbers would be 12, 14, and 16. So the rule that relates to the in and the out numbers in the table is the in is plus 1 and the out is plus 2, or the in is multiplied by 2 to get the out. Again, your homework for today is going to be, in addition to the warm-up, pages 260 and 261. And I guess Miss Kane was right. Miss Lauren Elizabeth has fallen asleep. So, the list of numbers in part A and B are called sequences. Sequences often have an underlining rule that is used to generate the numbers in the sequence. The numbers in a sequence are sometimes called the terms of the sequence. For example, 1, 2, 3, 4, 5, and so on are the terms of the sequence from part A. If you look at the in and the out table from the math message, I want you to see that when you worked with the in and the out tables in the past, you focused on finding the rule that described the relationship between the in numbers and the out numbers. What is the rule that relates the in numbers and the out numbers? Well, in this case, it would be double or multiply by 2. The difference between these two kind of rules you found in the math message. Rules for the sequences are used to generate a list of numbers. Rules that describe the in and the out relationships are used to find an out number that goes with the given in number. So what I want you to do is to look at the in and the out table again. What do you notice about the numbers in the column? Well, in the first column, they go up by 1. They are the numbers from part A. What else do you notice about the numbers in the out column? They go up by 2. They are the numbers from part B. The terms of sequences from part A and B have been matched up in the in and out table so that the first term from each sequence is now in the first row. The second term from each sequence is in the second row, and so on. These pairs of terms are called corresponding terms in the two sequences.
Each row of the table shows a pair of corresponding terms. For example, 3 and 6 are a pair of corresponding terms because they are the third term of each sequence. So we can also say that 3 corresponds to 6, or that each in number corresponds to the out number that appears in the same row or the table. The rule +1 can be used to generate the numbers in the in column, and the rule +2 can be used to generate the numbers in the out column. Why does the double or multiply by 2 make sense for the relating the corresponding in and out numbers? Well, every time the in number goes up by 1, the out number goes up by 2. This means that the number in the out column will always be twice the number in the in column.
Count to 2 and then you can go.
For your work today, you'll see the in and out tables, and I've completed the first one for you. The in is 1, the out is 2, 2, 4, 3, 6, 4, 8, 5, 10. It then asks you for ordered pairs. This is actually pretty easy. The in becomes the x, so the 1 is the same, and the 2 is the same. You'll notice for these numbers, I just basically rewrote those numbers. The in is all the x's, and the out is all the y's. Now for graphing these on a coordinate grid, what you'll have to do, and this is just a reminder, it's been a while, the x-axis, again, goes left and right, while the y goes up and down. So the 1, 2, I would go over 1 for the x-axis, up 2, and this would be point A. I would do the same for point B. 2 over 2, up 4, and that would be point B. I then would connect, starting here, moving up. So that's how you'll go ahead and complete the other 3 problems. That's how you'll translate those to the ordered pairs and then off to the coordinate grid.